All right, statistics. This is your last section of notes for chapter 2. And then we get back into review mode, and it's time to take a test. And we're trying to land on our feet, not faceplant ourselves right into the wall with this test. Here we go. 3 models that we use for scatter plots. 3 of them. We've just been talking one of them, the linear model, y hat equals a plus bx. And we talked about correlation, and we talked about r squared, and we talked about s, and residuals and residual plots. That all had to do with a linear model. Well, if it's curved, here's 2 more that we'll talk about in this chapter. The quadratic, now watch what I write here, y equals a plus bx, which looks like a line, plus cx squared. Now that is definitely not how you write that in algebra, but since we went a plus bx, we go a plus bx plus cx squared here when we're fitting equations to data. So that's a little bit of a different thing for you. And then the exponential model is y hat equals a times b to the x. And that is actually how you write that in an algebra class. So just real quick, I just want to write a quick graph of each one to show you exactly what you're looking at. The linear is a line. The quadratic model is a parabola, of course, and an exponential model usually flattens out on one side towards something called a horizontal asymptote, and then on the other side it takes off. And if you put a negative in front of it, opens down, little things like that. You don't have to be an expert in curves and algebra 2 and pre-calculus for this class. You just have to pick which one's better, okay? Now here's a bunch of data about NFL quarterbacks. I've got 2 variables, how old each quarterback was, and then look, I've got 1, 2, 3, 4 different rows of data here. How old each quarterback was and how many yards they threw in 2010. That's a while ago. A whole bunch of quarterbacks because there are a lot of teams, right? So then look, I made a scatter plot using a software package that we have called Jump on the server. Of course, can't put it on the Chromebooks. That would be too much to ask. Anyway, that's x and that's y, and that's what the scatter plot looks like. Now, that's clearly not just a line. I don't really know if a parabola fits that or an exponential curve. So what are we going to do? Let's go to the next page, and we'll start looking at some stuff. What I did on the next page is I used our Jump software to get a whole bunch of information in a hurry. Now you can do this stuff on the calculator as well, and I'll show you how to do that. But here's what I did. I made a linear. That's where you find out what form I just used. There's linear, and here is quadratic. It calls it a polynomial, but it says degree 2, and when the biggest thing you have is x squared, that's a quadratic, it's a parabola, right? And so, look right under it says what the fit is. It gives you the equation. All right, so both of these are the actual equation of best fit, and you can see there's a line, and there's a parabola, and those are the best fit lines and parabolas for this data. Okay, now a real important thing for us to focus on is right underneath where it says summary, there is r squared. R squared, now didn't you just learn that's called the coefficient of determination? R squared, the coefficient of determination. And then, because of the way the formula works, there's one down here called root mean square error. That one's actually S, the standard deviations of the residuals. I'd be a lot happier if it just called it the standard deviation of the residuals, but it doesn't. It calls it the root mean square error. Now you don't have to write this in your notes, but I'll tell you why. Because S is equal to the big square root of the sum of all of the residuals squared over n minus 2. That's a formula you saw in your notes yesterday. Well, look, if you add a bunch of things and then divide by n or n minus 2, you're finding an average. And it's the square root of an average. And it's the square root of an average where you added up the squares of the errors. That's how much you missed the line, right? That's a residual. That's what that is. So look, the root, square root, of the mean, we took an average, of the square of the error. So I don't know if you want to try and reason your way through that or just kind of memorize that phrase, root mean square error. That's the standard deviation of the residuals. Okay, and then underneath we have a residual plot. So here, I'm going to draw my line y equals 0 there. I'm going to draw my line y equals 0 there. And look at both of those residual plots and think which one, according to yesterday, what I should be looking for is which residual plot shows less of a pattern. I'm kind of seeing a curved pattern right here. And I don't see much of a pattern here. I mean, there's this going on up here, but it also goes on down there. So overall, there's not really much of a pattern. So the linear equation, I'm going to get that from up here. I'm going to use y hat, and I'm going to say it's 3,351.7 minus 4.79x. That's just what I took right there. And the r squared is 0.000678. Okay, the quadratic equation, that one's going to go y hat. I go with a constant first, so 2,346. I'm going to write small because I think we're going to have a lot of numbers to write down here. 0.2 plus 39.5, and that's times, it says age there, so I'm going to put an x, and then there's a minus, and it's minus 13.65, so I'm going to go 13.7, and that's x squared. So I could either use a line as an equation that goes, a linear equation to represent those points, or I can use a quadratic equation, which is a parabola that goes through those 2 points. The r squared for this one is 0.1764. Generally, the rule is the higher r squared wins. So since this r squared is 17 or 18%, and this one's less than 1%, this parabola does a better job of representing the pattern. Which quadratic shows less of a pattern? Which residual plot, that's these two right here. Which one of these shows less of a pattern? Like I said, this seems to be doing this as an overall, and this is less of a pattern. I'm going to say the quadratic. Which model is the better fit? We're going to go quadratic over linear. The parabola is a better fit. Why? R squared is higher, and the residual plot shows less pattern. There you go. I just compared two different models with several different ways. The original visual, then the equation and the r squared that went with it, and the standard deviation of the residuals that went with it. Basically, for those I didn't mention down here, but look, this s right here, 802 is actually smaller than 868. That means the average distance between the parabola and the points is smaller than the average distance between the line and the points. So I'm also going to add down here, r squared is higher, the residual plot shows less pattern, and I'm going to say and s is smaller. Those are three different measurements, or three different ways to assess how well your model fits that suggest quadratic is better. Go to the next page.